Tech Revision with Mrs. Swanee Pooh. Hi Year 11, this video is going to cover a couple of drawing techniques that you need to be aware of. The first one being system diagrams, which is this one here, which is a bit odd but not difficult to understand, so we're going to go quickly through those. And then these, which are called schematic, just checking the spelling there, schematic diagrams, which are a little bit weirder and more tricky to understand, but these both have different kind of uses, and both of these you need to know for the theory side of the GCSE course. So the first one we're going to have a look at is a system diagram. So these are really simple flowcharts that separate a system, and when I mean a system is basically something that does something. So for example, a light, a car motor, a TV, something that you have to push a button, it does something, and there is an output, so light, sound, you know, turning of the wheels, blah 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 blah. So a system is something that does something, so it could be basically like a machine of some kind. Okay, so what a system diagram does is it splits the actual system, the machine let's say, into an input, a process, something that happens, and then an output. Okay, and this is useful when developing a basic design for a system. So some of you that do computer science may see this kind of process used quite a lot for programming of different systems, but it can also be used in mechanical systems and in machines. What's also used, as well as these basic little input, process, output, you also have annotations, so little descriptions which outlines the kind of idea behind the system without going into too much detail on how exactly you'd make it work. So it's basically just saying this will happen, then this will happen, then this will happen. It won't say specifics of exactly how the electrical circuit might work, for example. And the annotations normally include the components or the mechanisms that will be used at each stage. And it gives a bit of a description of what they will do, but it should be kept really brief and to the point. They don't need to be very detailed. And also sometimes you can add some little doodles or some little drawings to show how the system works. So I've got an example on the next slide. So this is a really simple systems diagram for making a cup of tea. So we have the input first, that's spelt wrong. So we have an electric kettle filled with water. Wow, this is awful. The kettle is plugged into the electrical socket and the on switch is pressed. So that's the input. The on switch is pressed, it's plugged in and it's pressed. The process then, the tea bags are placed in the teapot, the water in the kettle boils, the boiling water is poured into the teapot and the tea brews. That's if you use a teapot. I'm not a teapot user, but there we go. Miss Saunders loves a teapot, so we use them at school. And then the output is you actually pouring the tea into the mug, the milk is added, and then you drink it. Okay, so we have all the way from the input of the hot water into adding the tea bags, leaving them to do their thing, and then the tea actually being poured out. So that's what comes out of the system. And the water is what goes into the system. Hope that makes sense. It's a bit odd, that one, but just remember you have an input, a process, and an output, and you keep it quite simple. Right, this one is, I know it says it there on the image, but I just want to make sure it's nice and clear for you. It's called a schematic diagram. Now these show the layout of a system. And this could be an electrical system, or it could be a mechanical system. Okay, it says it right there. So electrical or mechanical. Now there is a very simple example of a schematic diagram, and that is a circuit diagram, which I'm pretty sure you will all have done in science, probably physics I would imagine. where you have drawn a really simple circuit diagram with a battery, a switch, a bulb, and I would imagine that's probably a resistor. So this is an example of a schematic diagram, and there's lots of advantage to these. They are usually drawn later in the design process than the system diagram. So the system diagrams that we just spoke about would say something like the input, the switch is pressed, the process, electricity travels through the wire, sorry, that's terrible. And then the output is the bulb lights up and emits light, whatever. So that might be the simple system, but this shows it in more detail with the actual components. So it clearly shows how the components are connected up, and also it makes it quite easy to read and simple to draw, because what you'll notice is quite often these are not drawn to scale, so they are not to scale. Ooh. That makes it a big benefit, because it's easy then to read and understand, because things can be spread out nicely. They also use symbols, so that's a symbol for a bulb. So you don't have to draw like a little bulb, make it look all realistic. You can just use a symbol. And they can also be simplified, and they often use unrealistic graphics just to simplify things and make it easier to understand. The negative of this is they won't contain any sort of dimensions, obviously, because they're not drawn to scale, and they're not the most realistic, but it sort of just shows you how everything links together in an electrical or a mechanical system. So a circuit diagram is a really good example of a schematic diagram. We're going to go through, I'm going to show you a couple more examples. So here is another example of an electrical system, and this one is a circuit diagram, and it's a circuit diagram, but you could also call it a schematic, where you can see everything has been simplified, everything is laid out nicely, everything is spaced out, so it's not to scale, but you can quite easily see, for example, how things are connected together, the regulator connected to the switch and the fan and the lamp, blah, 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 blah. But that is a very, very simple schematic of an electrical system. They do get a little bit more complex, so some of you may have seen these kind of like repair manuals, and this would be for a mechanical schematic. I can think of a few people in my class who would love looking through one of these, and Mr. Johnson loves a transporter. So there we go, there's Mr. Johnson in his transporter. But these repair manuals often include not just electronic or electrical schematics, they include mechanisms like this. So it shows how all the parts connect. I mean, that absolutely blows my mind, that diagram there. But for someone who knows what they're doing with this, it allows you to see how everything joins together. It's almost like an exploded diagram in a way. But this is another example of a mechanical schematic diagram. Now, you might be thinking, what exactly do I need to know about these? Some of the advantages. So some of the advantages of these schematic diagrams, here we go. The first one, they are easy to understand. And it's easy to understand the relationship between different parts and components. So you can see where they fit together. Let's kind of moving on to this next point here. You can show how parts fit together. You can see where different components might be connected to other components. I'm trying to draw a really, really basic little circuit here. So you can understand how things are connected together. They use really simplified symbols to make them easier to read. That's definitely true of the circuit diagrams. The mechanical schematics tend to be a little bit more complex. And another advantage is they're not often drawn to scale. So the diagram can be really spaced out and laid out really, really clearly. So the actual thing might be all bundled up together with a bulb here and a battery here and all loads of wires everywhere. But it can be laid out really clearly on a circuit diagram, so you can see where everything is supposed to be connected. So that is the advantages of schematic diagrams. They are a type of drawing technique used in the design process, especially when you've got an electrical or a mechanical system. Okay, I hope that was useful. See you on the next video.